Okay then, here we go. Number 1, circle the point which lies on the curve y equals x squared minus 4x and 1. So each possibility has x coordinate minus 1. So substitute that in. We get y is minus 1 squared minus 4 times minus 1 and 1, which gives us 6. So it's minus 1, 6. Number 2, the height of a tree is 12 meters correct to the nearest meter. Circle in the error interval. Okay, so I do have error interval stuff linked down below. So for an error interval, we want the lower bound to be the smallest possible height the tree can be, which is 11.5 meters, and the upper bound has a strict inequality with the smallest height the tree can't be, which here would be 12.5 because that would round up to 13. So this one is our guy. Number 3. 2a is 5 times bigger than b. Circle the ratio a to b. Okay, first of all, let's get the equation. So 2a is 5 times bigger than b. So 2a is 5 times b. Now, the easiest way to do this is now to think of values of a and b which make this work. So the first thing 2 and 5 go into is 10. So for that, a would need to be 5, b would need to be 2. So the ratio a to b is 5 to 2. Question 4. We want to circle. There we go. Which of these represent the shaded area in the Venn diagram? So the first one, A union B, means A or B or both. So it's not that guy. The second one means A and B, but not, so not A and B. The third one means A and B, that is our guy. Okay, number 5, we have a loci and construction. So using a pair of compasses and a ruler, show the region inside the grid that is less than 4 centimeters from A and closer to B than C. Label the region R. Show all of your construction lines. Okay, so first up, for the region less than 4 centimeters from A, you need to set your compass to 4 centimeters, put the point on A and draw the arc of the circle around A inside of the grid. So anywhere inside of that circle is less than 4 centimeters from A. Then find the region closer to B than to C. You need to construct the perpendicular bisector of the line joining B and C. Anywhere above that line is closer to B. So the region we want is in there. I'll put my loci playlist down below in case you don't know how to do those two things. Okay, number 6. Beth drives 200 miles in 4 hours. She drives the first 18 minutes at an average speed of 36 miles per hour. Work out her average speed for the rest of the journey. Okay, so speed is equal to distance over time. Now for the first part of her journey, we need to work out how long that took it. So, for the first part, well, we know that her distance is 18 and her time, her speed was 36. Now we can rearrange the formula. If we multiply through by t, s times t is equal to t, and then time is distance divided by speed. So for the first part, time is distance, so 18 divided by speed, 36, so that gives us 1/2 of an hour. Okay, so now for the second part, we need to work out how much further she has to go. So her distance is 200 minus 18, which is 182 miles, and her time in terms of hours is 3.5. So her speed is 182 divided by 3.5, which gives us 52 miles per hour. Next up, we have a rectangle ABDE and a right angle triangle ABC. We are told the length AC is 17 centimeters, the length BC is 8 centimeters. Now we're told the ratio of BC to CD is 1 to 2, and we're asked to work out the area of the rectangle. Okay, so first up, let's deal with the ratio. Down below in the description, by the way, I have a whole playlist of ratio past paper exam questions, which you can download to try yourself. So, if BC to CD is 1 to 2, that means CD is twice as big as BC. So, CD is 16. Okay, so area of a rectangle is base times height, so we also need to work out the height of this rectangle. So, luckily, that is also the height of a right angled triangle. So, if we call this side A, this side B, this side C, we can use Pythagoras. So remember, A squared and B squared is C squared. So, A squared is C squared minus B squared. So here, A squared is 17 squared minus 8 squared. Now that is 289 minus 64, which gives us 225. So A is the square root of that, which is 15. So, now we can work out the area. The area is the base, which altogether is 24 centimeters, times the height, 15 centimeters, which is 360 centimeters squared. Okay, number 8. On the axes below, sketch the curve y equals x cubed minus 2. You must show the coordinates of the y-intercept. Okay, so at the moment, here is a sketch of y equals x cubed. All that the minus 2 does is bring the curve down 2 places. So the y-intercept is at 0 minus 2. Okay, number 9. In sport, injury time is time added to the end of a match. The table shows information about injury time, 2 minutes added to 380 matches. Part A asks us to circle 2 words that describe the data. So, is it continuous or discrete? Well, discrete is data that you can count. So, the number of sweets in a bag, the number of days in a week. Continuous is data that you can't count, and it can have decimal places, such as, so you could have like 1 minute, 1.1 minute, 1.11 minutes, etc. So continuous is our guy. And we're in a grouped frequency table, so it's grouped. Okay, then part B asks which interval contains the median. So the median is the middle. So the first thing we need to do is half the number of matches. Now that gives us 190. Now, if we were asked to find the actual median, because we have an even number of things, the median itself would be the average between the 190th and 191st match. But luckily we're not asked to do that, we just want the interval containing the median. So now we go through the frequencies and add them up until we get a number either 190 or greater. So 59 and 158 is 217. So the median lives in the second interval. T is greater than 2, less than or equal to 4. Okay, then part C, what percentage of the games had more than 6 minutes of injury time? Okay, so the two that we are interested in then are these guys. So 45 and 12 is 57. So as a fraction, it's 57 out of 380, which is 0.15, which is 15%. Okay, number 10, inequalities. So x is an integer. X is greater than minus 4, but less than or equal to 2, and x at 3 is greater than or equal to 2, but less than 9. Work out the possible values of x. Okay, so from the top one, now this tells us x can be minus 3, minus 2, minus 1, 0, and 1 and 2. Now, for the bottom one, we need to solve it. So, we need to subtract 3 from all 3 parts. So we get minus 1 is less than or equal to x. is less than 6. So this one tells us x is allowed to be minus 1, 0, 1, 2, 3, 4, and 5. That x is only allowed to be numbers that satisfy both. So x can be minus 1, 0, 1, and 2. Okay, number 11, more ratio. So again, remember, there is a playlist down below with 5 sets of downloadable past paper exam questions on ratio. It's a good time. So, Joe and Kyle share an amount of money in the ratio 7 to n. So, J to K, 7 to n. Joe gets 35% of the money. Work out the value of n. Okay, so if we know Joe gets 35%, that means Kyle gets 65%. So the ratio could be written as 35 to 65. Now that has a common factor of 5, it goes down to 5, no it doesn't, it goes down to 7 to 13, so n is 13. Number 12, a biased coin is thrown 250 times. The relative frequency of heads is worked out after every 50 throws. Circle the best estimate of the probability of heads. Okay, so relative frequency is the number of times the event you're interested in happens out of the total number of times the trial was done. So the more times you do a trial, the more accurate your results. So the most accurate is going to be 250 throws, which gives us 0.3. Okay, number 13. The amount spent on clothes by 40 boys and 40 girls in 1 month were recorded. The table shows information about the amounts for the boys. We're told the mean for the girls was £35. We want to estimate the mean of the girls as a percentage of the mean for the boys. So we're going to need to work out the mean for the boys. So they've labelled the first column for us. We do indeed need the midpoints. So 0 to 20, that's 10. Then 30. Then 50. And then 70. Okay, now in the second empty column, we do the midpoints times the frequency. So 10 times 22 is 220. 30 times 9 is 270. 50 times 6 is 300. And 70 times 3 is 210. Now we add those 4 numbers together to give us an estimate for the total. So if we add those together, we are going to get, that's nice, 1,000. Now to find the mean for the boys, we do the total divided by the number of boys. So 1000 divided by 40. Which gives us 25. Okay, so we want the mean for the girls as a percentage of the mean for the boys. So as a fraction, that's 35 out of 25. Now that simplifies to 7/5, which as a decimal is 1.4, which finally as a percentage is 140%. Okay, number 14, Ali and Mel are making 3-digit codes. Good times. The digit 0 is not allowed. Ali only uses odd digits. Mel only uses even digits. Ali can make X more codes than Mel. Assume that digits cannot be repeated. Work out the value of X. Okay, so for Ali, odd digits are 1, 3, 5, 7 and 9. So she has 5 to choose from. Now if digits can't be repeated, she's then going to have 4 to choose from for the second digit, and then 3 to choose from for the third. So to work out our total number, we do 5 times 4 times 3. Which gives us 60. Now for Mel, if we're not allowed 0, then even digits are 2, 4, 6, 8. So she only has 4 to choose from originally. So 4 for the first, 3 for the second, 2 for the third. So that's 24. So X is 60 minus 24, which is 36. And part B, we're told, in fact, digits can be repeated. What does this tell you about the value of X? Okay, so we could work it out. If digits can be repeated, then, let's work it out. Ali, she would be able to have 5 for the first, 5 for the second, 5 for the third. So she would have 125 possibilities. Mel has 4 for the first, 4 for the second, 4 for the third, so that would give her 64. So X would be 125 minus 64, which is 61. So X would be bigger than our value in part A. Okay, next up, here is the line L and the graph of y equals x minus 1. The scale on the axes is not shown. Work out the equation of the line L. Okay, so to do that, we are going to need to find the scale on the axes. So, y equals x minus 1 is going sloping up from left to right. Now remember, y equals mx and c. C is the y-intercept. So, on y is x minus 1, the y-intercept is minus 1, which gives us our scale on the y-axis. So the y-intercept of L is 3. So, up to there, we can say that L is y equals mx add 3. So we now need to find the value of m. Now to do that, we're going to need to find another point on the line. So we're going to need the point where it crosses the x-axis. To do that, we need the scale. So what we can do is find the x-coordinate here on y equals x minus 1. So on the x-axis, y is equal to 0. So here, 0 is x minus 1. So 1 is equal to x. So along x, every 2 big squares represents 1. So the x-intercept of L is 2, 0. Okay, so now to find the gradient, gradient is difference in y over difference in x. So the gradient of L, so the coordinates over here are 0, 3. So we can do 0, take 3, over 2, take 0. Now that gives us minus 3 halves. So L as equation y is minus 3 halves x add 3. Okay, next up, ABC and ACD are triangles. The area of ACD is 80.5 centimeters squared. Work out the area of ABC 2, 3, 6, 6. Okay, so in ACD, we know one length and an angle. Now, we can work out the area of a triangle using trigonometry. So here's the page from my formula booklet. If you haven't checked out this video yet, it's linked down below with all the formulas you need to know. So to work out the area of a triangle with trig, we need an angle and the two sides coming out of it. So the problem at the moment is we only have one side coming out of the angle. So at the moment, let's call that x. Now, we know the area of the triangle on the right is 80.5 centimeters squared. So, area of a triangle normally is base times height divided by 2. So we know 14 times x divided by 2 is equal to 80.5. So that tells us 7x is 80.5 divided by 7 x is 11.5 centimeters. Okay, so now that we know that, we can now use trigonometry to work out the area of ACD. So the area of ACD is 1/2 times 19 times 11.5 sine of 36. Now to 3 sig figs, that gives us 64.2 centimeters squared. Okay, number 17, m is equal to b minus 2b all over 2. P is 68.3, correct to 1 decimal place. B is 8.7, correct to 1 decimal place. Work out the lower bound for m. Okay, so the first thing we're going to do is write down the error intervals for P and B. So, the smallest thing P could be would be 68.25. Now, the smallest thing P cannot be would be 68.35. Now, for B, smallest thing B could be would be 8.65. Smallest thing it can't be is 8.75. So we want the lower bound of m, so let's call it m. L. So we want the smallest possible number on top. So we're going to have 68.25 minus 2 lots. Now we're going to subtract the biggest amount we possibly can. So even though B cannot be 8.75, that's the value we use as the upper bound. So minus 2 lots of 8.75, that's all over 2. And you should get 25.375. Okay, number 18, a nice bit of ratio. So remember, down below there's a whole playlist of ratio exam questions you can download and print off yourself. So there are blue discs, green discs and white discs in a bag. There are 4 times as many blue discs as green discs. So straight away, let's turn that into a ratio. So blue to green is 4 to 1. And the number of blue discs to the number of white discs is 3 to 5. Okay, one disc is selected at random. Work out the probability that the disc is either blue or white. Okay, so to do that, we are going to need to combine the 2 ratios. So to do that, we look at the thing in both ratios. So here, that's blue. And in each ratio, we're going to turn that part into the same number. So the first thing 4 and 3 go into is 12. So the blue to green ratio is 12 to 3. And the blue to white ratio is 12 to 20. So altogether, we could write blue to green to white is 12 to 3 to 20. Now, altogether, that ratio has 35 parts. Now we want the probability of getting a blue or a white, so we add those parts together. So 12 add 20 is 32, so it's 32 out of 35. Okay, next up, we want to work out the area of this trapezium. Seems simple enough. So again, if you don't know this formula, here it is in my formula booklet. So we need the top two lengths and the height. So the striking problem here is that we don't have the height, but we do know this angle of 64 degrees. So this is a good example of SOHCAHTOA trigonometry being hidden in other shapes. So the reason we're going to use SOHCAHTOA, and I've got playlists on SOHCAHTOA down below, one explaining how to do it, and one full of exam questions. So we can make this into a right angle triangle. Now because the top is 11 centimeters and the base is 15, the base of this triangle is 4. Now in terms of the angle, the height is the opposite, 4 is the adjacent. So that tells us tan 64 is the opposite over 4, therefore the opposite is 4 tan 64. Now to one decimal place, that gives us 8.2. So that tells us the height of the trapezium is 8.2 centimeters. So now that we have that, we can work out the area. So the area is the height, so 8.2 times the top and bottom added together, so 26, all divided by 2. Now that gives us 106.6 centimeters squared. For 20, here we have algebraic proof, so I have a whole playlist again of downloadable past paper exam questions linked down below. So expressions for two consecutive triangular numbers are n times n add 1 over 2 and n add 1 times n add 2 over 2. Prove that the sum of consecutive triangular numbers is always a square number. Okay, so sum means to add together. So the sum here is going to be, now both fractions have a 2 on the bottom, so we can just add across the tops. So we have n times n add 1 add n add 1 times n add 2 all over 2. Now let's expand up on top. So n times n add 1 is n squared add n. Now n add 1 times n add 2 is n squared add 3n add 2. That's all over 2. Okay, if we now simplify the top, we have 2n squared. We have n add 3n, so that's 4n. And we have the plus 2 at the end. That's all over 2. Now luckily everything on top is divisible by 2, so this is n squared add 2n add 1. Now, how do we prove that this is a square number? Well, it factorises to n plus 1 times n plus 1, which we can finally write as n plus 1 squared. So it's always a square number. Number 21. A solid shape is made by joining two cones. Each cone has the same radius. One cone has a slant height of 2 times the radius. The other cone has a slant height of 3 times the radius. We're told the surface area of the shape is 57.8 pi centimeters squared. We're told the curved surface area of a cone is pi RL, where L is the slant height. Our job is to work out the radius. So let's call the cones A and B. Now we know A is the smaller one, so for A, the slant height is 2 times the radius, so L is 2R. So the curved surface area there, let's call it CSA, is pi R times 2R. So that's 2 pi R squared. Okay, and then we'll do the same for B. So here, we know the radius is, the slant height is 3 times the radius. So L is 3R. And this time, the curved surface area then is pi times R times 3R. So 3 pi R squared. That means then the total surface area is 5 pi R squared. Now we also know that that is 57.8 pi. So from that we can now find R. So we can divide through by pi, so 5R squared is 57.8. Divide through by 5, we get R squared is 11.56. And then finally, square root, we get R is 3.4 centimeters. Okay, number 22, we have surds. So down below I have a video full of surds, past paper exam questions, which you can download to try yourself. So here we want to show that 5 root 3 minus root 12 squared simplifies to an integer, so a whole number. So first up here, the first thing I would do is simplify root 12. So root 12 is root 4 root 3, which is 2 root 3. So now inside the bracket, we have 5 root 3 minus 2 root 3. So we now have 3 root 3 squared. Now this means 3 root 3 times 3 root 3. Now that is one long chain of multiplication. So we could think of that as 3 times 3 times root 3 times root 3. Now 3 times 3 is 9. Root 3 times root 3 is 3. 9 times 3 is 27. Okay, number 23, A and B are similar cuboids. Surface area of A to surface area of B is 16 to 25. We want to work out the volume of A to the volume of B. Okay, so we have the surface area ratio of A and B, and we want the volume ratio. So we can't get directly to volume from surface area. We need to get the length ratio. So to get the length ratio from surface area, we square root both parts. So that's going to be 4 to 5. And then we can get the volume ratio from the length ratio by cubing. So the volume ratio is going to be 64 to 125. Okay, next up we have a quadratic inequality. So we have the graph of y equals x squared add 4x minus 12. We want to work out the values of x for which x squared add 4x minus 12 is less than 0. Give your answer as an inequality. So, graphs are visual representations of the values of expressions. Above the x-axis, they are greater than 0. On the x-axis, they equal 0. Below the x-axis, they are less than 0. So we want the x values that create the part of the graph below the x-axis. So this bit down here. Now to do that, we need to find the x coordinates of the x-intercepts. So that point and that point. So at those 2 points, the expression is equal to 0. Now, luckily, we can factorize that. So that's x plus 6 times x minus 2. So the solutions are then x is minus 6 and 2. So we want the part of the graph between those 2 points. Now x is not allowed to equal minus 6 or 2 because we want the graph to be strictly under the x-axis. So we want x greater than minus 6 and less than 2. Okay, number 25, we have some histogram fun, so my histogram's content is down below. So a sample of 50 eggs were taken from farm A. The table shows information about the masses of those eggs. A sample of 50 eggs was taken from farm B. The histogram shows information about the masses of those eggs. We are then told, for a medium egg, the mass has to be between 53 grams and 63 grams. We are told the farm A sample has more medium eggs than farm B. Use the table and the histogram to estimate how many more. Okay, so if we do farm A first. So farm A is nice and easy. We want the eggs between 53 and 63. We want those top 2. So 8 and 19 is 27. Now for farm B, we're using the histogram. Now with histograms, the area of the bars represents the frequency. So let's first of all find where 53 is. So 53 is going to be here. Now we then want the area of this first bar to the root of that blue line. So the width is 2, the frequency density is 1, so the frequency in there is 2. Now we need to find 63, so that's going to be about there. So we now want the area inside this second bar between 53 and between 55 and 63. So that's a width of 8 and the frequency density is 2. So the frequency in there is 16. So for farm B we have 2 plus 16, Johnny Good Day is 18. So we want to know, or an estimate for how many more there were in farm A. So 27 take 18 gives us 9. Now the reason it's an estimate is because we don't know the exact values of the eggs in the histogram. So we split bars into the parts we wanted. So for example, in the first bar, it might be that no eggs were between 53 and 55 grams. Or it might be that they were all between 53 and 55. We don't know. So it's an estimate. Okay, number 26, we have an identity. So x add 5 times x add 2 times x add a is identical to x cubed add bx squared add cx minus 30. Work out the values of the integers a, b, and c. So, the 3-line equal sign is an identity. We're not trying to solve. What we need to do is make the left-hand side identical to, so exactly the same as the right-hand side. So, a good way to start here would be to multiply x add 5 by x add 2. So the left-hand side is x squared add 7x add 10 times x add a. Now, looking at the number, the constant term on the right, it's minus 30. Now, the only way that we're going to get that when we expand this left-hand side is 10 times a. So, 10a has to be minus 30. From that, divide by 10, a then is minus 3. So now the left-hand side is x squared add 7x add 10 times x minus 3. Now to work out b and c, we're now going to expand these two brackets. So I would always recommend using a table to do this. So we're going to have x squared 7x and 10 across the top, and then x minus 3 down the side. So x times x squared is x cubed. Minus 3 times x squared is exactly that. X times 7x is 7x squared. Minus 3 times 7x is minus 21x. X times 10 is 10x. Minus 3 times 10 is minus 30. So, if we bring that out and simplify, we have x cubed add 4x squared. So that means b is 4. A was minus 3. Then we have 10x minus 21x, so that's minus 11x. So c is minus 11, and then we got the minus 30 on the end. Okay, now the final question, we have functions, so I have two playlists on these down below. One explaining all the different techniques, and one full of downloadable past paper exam questions. So, here, f of x is 2x over 5 minus 1. We want to work out the value of f inverse of 3 add f of minus 0.5. So, first of all, we can work out f of minus 0.5. So, all we're doing there is substituting in x is minus 0.5. So, we're going to get 2 times minus 0.5 over 5. So that's minus a fifth minus 1. Now that is minus 1.2. Okay, now remember that. Okay, now to find the value of f inverse of 3, we need to find f inverse. So, some teachers will tell you to call your function now y, but y, don't, just call f of x f. So, f is 2x over 5 minus 1. Okay, so we now need to make x the subject of this. So we're going to add 1 to both sides and multiply through by 5. So we're going to get 5f add 5 is equal to 2x. And then we're going to divide by 2. So 5f add 5 over 2 is equal to x. Now at the end, x and f swap places, and f is now the inverse function. So this tells us that f inverse is 5x add 5 over 2. So now we can find f inverse of 3. So that's 5 times 3 add 5, which is 20, over 2, which is 10. So finally, we get 10 add minus 1.2, so 10 minus 1.2 gives us 8.8. And guys, that's the end of this paper. Really hope you found it useful. Remember, I have a playlist down below with every higher AQA past paper walkthrough so far. There's also lots of useful stuff in the description, so check that out.